Let's try practicing with the fundamental counting principle. So, in the first example, there's a person called Julie, and Julie has a meeting today. She goes to her closet, and she finds that her closet has 5 different shirts and 3 different pants. And then Julie asks herself, how many ways can she dress for the meeting? This is almost a direct usage of fundamental counting principle. How many ways are there for event 1 to happen, aka how many ways are there to choose a shirt? There are 5 ways. 5. How many ways are there to choose pants? 3 ways. Does choosing the shirt affect choosing the pants? No, it doesn't. So right away, we go 5 times 3 equals 15. So there are 15 ways that Julie can dress for this meeting. So that's by using the principle itself. If you want more intuitive reason, think of it this way. If one shirt has 3 pants, 2 shirts can have 6 pants, then 5 shirts should have 15 pants. And each pant technically is a way of dressing. Our next example is about restaurant. So you work at this awesome company, and this company is very nice, and they give out free meals. Each meal consists of exactly 1 drink, 1 main dish, 1 side dish, and 1 snack. So you wonder, how many different meals are possible? So this is very similar to the previous question. We should first ask ourselves, what are the events? Event 1 is drinks, event 2 is main dish, event 3 is side dish, event 4 is snacks. How many ways can we have a drink? Well, there are 4 ways to choose a drink. How many ways can we choose a main dish? There are also 4 ways. How many ways side dishes? 2 ways. How many ways snacks? 3 ways. And it's important that choosing a drink does not affect choosing a snack or a side dish or a main dish. So all these events are independent of each other. It doesn't matter what we choose from one category. It's not like that would affect another category. So if we apply the fundamental counting principle, we multiply all this together. 4 times 4, 16, 32, 96. So there are 96 distinct ways of getting free meals. Distinct free meals. Our third example is about traveling. Let's say you want to go on an airplane. You want to go from Toronto to San Jose. But in the middle is Denver, and your plane has to stop there to refuel. I guess that makes sense. Yeah, it's a small plane, so it has to refuel. Each of these white lines represent path lines, well, the flight path. So the question is, how many total ways can your plane fly from Toronto to San Jose? In this case, we should first ask ourselves, can we apply the fundamental principle right away? So how many ways are there to go from Toronto to Denver? 1, 2, 3, 4, 5. 5 ways. To go from Denver to San Jose, 3 ways. So that's a total of 15 ways. And don't forget, there are 2 ways that you can go from Toronto directly to San Jose. So that would be 15 plus 2 for a total of 17 ways to go from Toronto to San Jose. It's important to make sure that when you do this multiplication, you multiply 5 times 3, not 1, 2, 3, 5, 6, not 7 times 3. Because 7 times 3 is different. For 5 times 3, there are 5 ways to go from Denver, and in 3 ways from Denver to San Jose. 7 times 3 would imply that there are 7 ways to get to Denver, but there are only 5, so 5 times 3. And then in the end, we add the 2 additional ways to go directly from Toronto to San Jose. You arrive at San Jose, and then you meet this great mathematician. The mathematician gives you this question, and the question is, count the number of counts. And this one came from the Art of Problem Solving book, Competition Math for Middle School. And the rules go like this. Count the number of different ways the word count can be spelled by connecting 5 letters in the diagram shown below, starting with the letter C and always connecting a letter to one of the 2 below it. So if we start at C, C-O-U, say N-T. In total, how many ways are there to do this? We can call event 1 the number of ways to connect a C with an O. How many ways? There are 2 ways. We can say event 2 to be the number of ways to connect an O to a U. How many ways are there to connect each O to a U? There are also 2 ways. For example, this O can connect to this U or this U. This O can connect to this U or this U. So each O can connect to 2 U's. How many ways can each U connect to an N? 2 ways. And how many ways can each N connect to a T? There are 2 ways. So this is for a total of 16 ways of forming the word count. A bit of a warning for this question is that it's in a very different format than our previous examples. But the same concept works because each event, each way of counting from one tier to the next tier is independent of how the previous tiers have gone. And each, element, each thing in each tier has 2 ways. So that's why we are allowed to do 2 times 2 times 2 times 2 for a total of 16 ways.